but not fantasy. Can we survive in space? The quest investigates one of mankind's greatest challenges. Less than 4 decades ago, we took our first steps beyond the Earth. The year was 1961. Soviet cosmonaut Yuri Gagarin orbited our home planet in a brief journey of 1 hour and 48 minutes. Since then, more than 300 men and women have spent a total of 38 years facing the rigors of space travel. Space is inhospitable to humans, a chilly void with neither air nor water. Even inside the most technologically advanced spacecraft, zero gravity exacts a crushing toll on the body. Close confinement and homesickness wear down the mind and morale. The longer the journey, the worse the effects. So far, no astronaut has ventured beyond the moon, but that's about to change. Plans are underway for a manned mission to Mars, 300 million kilometers away, 1,000 times further than the moon. And that's only one project being contemplated. Work has begun on the International Space Station. This ungainly array of scientific laboratories, living quarters, computers and equipment, both to power the ship and support life aboard, will weigh almost 500 tons. It'll cover an area larger than a football field. By 2002, it'll be circling the Earth, our first space colony. Even now, researchers are racing to find ways to make life bearable aboard the space station and on longer missions. The first challenge of space living is the part that seems like the most fun, weightlessness. Our bodies seem to adapt to it remarkably well. The immediate side effects are mild disorientation and nausea, caused by increased blood flow to the head. Without gravity, our hearts don't have to work very hard to pump blood around the body. Muscles and bones get little exercise, freed as they are from the tug of gravity. The problem is that all our bodily systems were designed to work with gravity. Very quickly, humans in space begin to weaken. Muscles shrink, blood vessels become inefficient, and bones degenerate. Our bodies literally start to waste away. The aging process accelerates. Yet we don't notice the changes as long as we remain in space. The trouble begins when we come back down to Earth. At NASA's Mission Control in Houston, Texas, flight physician Michael Barrett monitors the changes in the bodies of returning American astronauts.
Now, those changes include bone loss, about 1 or 2% out of the skeleton per month. Also muscle loss, because the human body is used to working against a gravitational load, and even walking across the street constitutes exercise on Earth. You don't have those types of loadings in zero gravity.
On the International Space Station, weeks will stretch into years without gravity. How will the first space colonists cope? The longest anyone has remained in space is 437 days. That record was set by the cosmonaut Valery Polyakov in 1995, aboard the Russian space station Mir. Unfortunately, the Russians kept poor records of Polyakov's health upon his return. Though he kept up his exercise regime in space, he was still too weak to walk out of the spacecraft when he landed. It took days for him to recover his Earth legs. In the thaw that followed the end of the Cold War, science took a great leap forward. In March 1995, an historic mission began. American astronaut physicist Norman Thagard was launched into space aboard a Russian rocket bound for Space Station Mir. Along with 2 Russian cosmonauts, Thagard would live there for 111 days. The mission's primary goal was to study the long-term effects of weightlessness on the human body. Every bodily function and nerve response was rigorously monitored. Thagard couldn't move a muscle without it being recorded. When he returned to Earth, Norman Thagard wasn't the man he used to be.
Physiologically, I lost between 15 and 20% of red cell mass, so I was anemic when I came back. I lost almost 12% of bone mineral from the femur, which is the bone in the upper part of the leg. About 20% loss in the calf muscle, 10% in the thigh muscle. My aerobic capacity, which is a measure of cardiovascular status, was down quite a lot.
Once back on Earth, muscle loss and cardiovascular deterioration are reversible with physical therapy and exercise. But bone loss is a one-way trip.
You're going to be ALS most of the time for a while.
Little is known of the long-term hazards of staying in zero gravity, but few want to risk it. To stay in shape on long missions, astronauts and cosmonauts will need to be far more disciplined about working out than most Earthlings. As on Earth, exercise bicycles and treadmills give the heart a workout. But in space, astronauts must be strapped in to keep them from floating off the equipment. Keeping muscles in shape presents a tougher problem. Weightlifting is out of the question, because in space there's no weight to lift. At NASA's Ames Research Center in Mountain View, California, researchers are exploring an ingenious alternative: astronaut-powered artificial gravity machines. One device is a human centrifuge. The faster the astronauts pedal, the faster they rotate. It looks like good fun, a space-age carousel, but there is a method behind the madness. The centrifugal force they produce simulates gravity. The artificial gravity creates resistance against which the astronauts' bones and muscles can be exercised, keeping them strong and toned. A second such device is a treadmill with a twist. This prototype will be used on the space station. The astronaut slides his lower body into a vacuum chamber. As air is pumped out, his body is sucked in, forcing his feet against the track.
45 millimeters of mercury, Rex.
Increasing the vacuum increases the force the astronaut feels. The greater the force, the more effort it takes for him to run. The idea of creating artificial gravity isn't new. In the 1950s, before the first satellite rocket ever left the launch pad, science fiction writers and artists were filling outer space with high-tech hardware. They foresaw the need to conquer weightlessness, just as modern space agencies do, although their solutions were grander, according to award-winning American illustrator Vincent DeFate.
The earliest space stations that were suggested were really toroids, wheels that rotate in order to create a kind of centrifugal gravity. And on their interiors, they would be completely Earth-like with, with manicured parks and rivers and whatever else.
The giant spinning space station is still decades ahead of its time. But that hasn't stopped the science fiction world from imagining ever more elaborate space outposts.
Over time, I think we have come to discover other ideas that work well, and now we know that a space station can look like almost anything.
And orbiting space stations are only the beginning. Why not a space colony on another planet? Sounds outlandish? It may be just around the corner. Within our own galaxy, astronomers have found 8 solar systems that resemble ours. Any may have planets that could support humans. Some may even contain other forms of life. For now, getting to these solar systems remains beyond our reach. But one interplanetary stop lies closer to home: Mars. Unmanned explorers are already en route to the Red Planet, hungry for data. They're programmed to beam back volumes of information, making a manned flight to Mars possible as early as 2008. With current technology, the round-trip voyage will take 2 years, longer than anyone has yet stayed in space. But even a trip to Mars is just the beginning. The first travelers to make the trek will be in for a bumpy ride. We already know some of the problems they'll face: nausea, anemia, headaches, disorientation, depression, motion sickness, and fatigue. None is life-threatening, but each is unpleasant, and any could keep a crew member from performing vital tasks. But a trip of this duration poses a still graver threat. Suppose an astronaut fell seriously ill. NASA is already on the case. When the International Space Station is deployed, it'll have in place a prototype system allowing doctors on Earth to treat orbiting patients. Using the telemedicine console and a satellite link, the ailing astronaut will be able to describe his symptoms to the physician. By attaching a few sensors, the space patient can download his vital signs, enabling the doctor to make a diagnosis or monitor a course of treatment. Keeping astronauts healthy is one thing. Can we also keep them happy? In part, that'll depend on whether crew members get along. Think of being trapped on a long flight in a crowded airplane with people who you don't know and may not even like. How long could that nightmare last? In a worst-case scenario, maybe 10 or 15 hours. Now imagine traveling for months, even years on such a flight. Would you have the right stuff for such a mission? Patricia Santi is a psychologist who evaluates aspiring astronauts.
We have seen, even on short missions, that there's an increase in irritability and interpersonal tension. On short missions, though, most people have the motivation to keep their mouths shut and their opinions to themselves, even if they don't like the way somebody's personal hygiene is, or the fact that they're not taking their share of the housekeeping activities. But when you're talking about 6 months, 2 years, let's say, that you have to be with somebody, it takes more than just grit and determination. It also takes some degree of psychological compatibility to make it work for the crew as a whole.
Locked in your spaceship, the only retreat is in your mind. Some astronauts lose their temper, others lose their grip. During one spacewalk, an American shuttle astronaut was awestruck by the sight of a tiny Earth engulfed in an infinite universe. He ignored calls from his commander to return to the shuttle and had to be dragged back inside. A prolonged sojourn in space left a group of cosmonauts so annoyed with their superiors on Earth that they mutinied. They refused to follow orders, turned off their microphones, and ignored all communications from Earth for weeks.
That's obviously a potentially dangerous situation. There's also examples of cosmonauts who became homesick and lost interest in their work until the mission was nearing its end.
In a bid to ease the monotony, Mir officials now allow cosmonauts to conduct regular home visits with loved ones. They call it FamilyCom.
FamilyCom was once a week, and the Russians do that. They do provide each crew member a chance to speak with their families. Sometimes it's a video conference, two-way video as well as audio.
But weekly video conferences with the family won't suffice as missions stretch into years. There's another solution to loneliness, although space agencies shy away from discussing it. As mixed crews become the rule, intimate relationships are inevitable.
Where men and women go, sex is sure to follow. The way to deal with that is obviously not to condemn or judge it or try to prevent it from happening, because you know as well as I do, even in offices where there's a ban on such thing, it happens all the time. It's a normal human function. The issue is, when does the behavior impact the mission in a negative or adverse kind of way? And that you have to leave to the mission commander to determine.
Will tomorrow's Captain Kirk need to be as skilled in human relations as in navigation? It may be a requirement, especially as the not-too-distant future promises whole lifetimes in space. One day, the human race will need a new home. 5 billion years from now, the sun will begin to fade, its nuclear fuel spent. Without the sun's energy, the Earth will die. But we'll probably need to evacuate long before that. We live on an endangered planet. Overpopulation, pollution, species extinction, nuclear war, all threaten the health of the Earth. Someday, only one course will be open to us: learning to survive in space and finding a new place to call home. The nearest solar system to Earth is Alpha Centauri, 40 trillion kilometers away. At the fastest the space shuttle can travel, it would take over 180,000 years to reach Alpha Centauri. Even if technology allowed us to travel at half the speed of light, so we could cover 150,000 kilometers per second, it would take us over 8 years to get there. According to Lawrence Krauss, a physicist at Case Western Reserve, just accelerating to reach that speed would be unendurable.
I calculated that to go at a rate, the same rate as our astronauts go up in the space shuttle right now, about a force of about 3 Gs, you feel a force pushing you with 3 times the weight of your own body, which is not comfortable. Imagine lying down and having 2 people sit on you for a while, but you can survive it. Even at that kind of incredible acceleration, it would take about 2.5 months to get to half the speed of light. So imagine lying there with 2 people sitting on you for 2.5 months. It's not so easy.
Even if we could get to Alpha Centauri, there's no evidence that its planets will be habitable. So we'd probably have to go much further afield. But before we wander off to the far corners of the galaxy, NASA engineers want to explore our own neighborhood. And that means learning to live on Mars. 1/3 the size of Earth, Mars is a desolate, frozen world. But it wasn't always so. Once it was a much livelier place. Huge extinct volcanoes, one 3 times as high as Mount Everest, testify to its turbulent past. A gigantic fissure scars its surface, the Valles Murinaris, 2.5 times deeper than the Grand Canyon. It was formed by shifting plates early in the life of the planet. The dried-up remains of ancient rivers wind across the Martian surface. For scientists at Ames Research Center in Mountain View, California, those dusty Martian rivers are brimming with potential. Astronomer Alan Welsh has no doubts about which planet is the next frontier.
Well, I personally eventually think that humans are going to live permanently on Mars, or at least for long periods of time. This won't be probably in our lifetime, but the steps in that direction will be taken in our lifetime. I can see colonies, and I can see some people who would be willing to spend their entire lives there.
Despite its harsh environment, Mars has almost everything to sustain a human colony in space. It's shrouded with carbon dioxide. Combined with hydrogen imported from Earth, the atmosphere could provide methane for energy and oxygen to breathe. The mineral content of Martian soil is richer than Earth's in lead, potassium, sodium, and zinc. Many other minerals are present, including gypsum. Bake gypsum, add water and a sprinkling of Mars iron-rich dust, and you have concrete to build houses with. With shelter and energy taken care of, future colonists could turn to their main task, transforming Mars into an Earth-like world. The process is called terraforming. It begins by bringing water to the Martian surface by importing it, manufacturing it, or if we're lucky, pumping it out of the ground. Then we'd import simple bacteria and plants, later more complex organisms to mimic the evolution of life on our own planet. In about 300 years or so, Mars could conceivably look like Earth. It won't be easy, but Norman Thagard believes survival in space is within our grasp.
I think that ultimately humans can do what they want in space. It's not a technological matter, really. It's a matter of will. It's a matter of spending the money to do it.
Yesterday, the Moon. Tomorrow, Mars. As technology reaches towards the edge of the universe, we work hard to prepare the human body and mind for the journeys ahead. 5 centuries ago, bold mariners sailed off to find new worlds on Earth. Now we look to space. As in the past, our imagination precedes us.
Lake monsters surf the waves next on Discovery Channel as the supernatural goes in search of Nessie's American cousin, Champ.